everyone. Thank you for staying this late for a session, hands-on session on jextract and transforming some native code gems to Java treasures. I'm just going to give you a brief intro in what we're doing today. But first of all, I want to introduce myself. I'm Ana. I'm currently working as a developer advocate in the Java team at Oracle. And I particularly enjoy working with the team that contributes and makes jextract amazing. So this is a tool that's very dear to my heart. And I hope I'll do justice with this presentation today. I have some demos. I hope I have time to do them all. So let's jump into the problem that we aim to solve today. So it can happen that in the lifetime of a Java developer to work on Java applications that need to integrate with native libraries. And well, there are many great Java libraries, but there's a lot of other libraries out there that are native-only libraries. And these libraries won't be, and they don't need to be written in Java. And just to give you some examples, these libraries usually are system APIs, Bluetooth, USB. You have them on your laptops. Usually they have frameworks written in different languages. For example, I'm using a Mac. This means Objective-C most of the time. Machine learning. So machine learning, they're using their own languages as well, like Tensorflow, for example. Then off-CPU computing, CUDA, OpenGL, and many, many others. Graphics processing. Just think of OpenGL, Vulkan, DirectX, and everything that games can put into using. There's also advanced mathematics that sometimes is using these foreign programming languages. And there's also others like OpenSSL, Creo, Fuse, and many more. So if you are in that situation of needing to integrate with such a library written in different languages than Java that are native languages, one way that we can solve this situation is by putting something that's called FFM bindings in between. So, but they're not exactly in between because, well, actually what they mean, it means that, well, the interaction between the JVM and the foreign non-Java APIs is being done simpler thanks to foreign function and memory API. And probably you've heard about this API. Raise your hand if you've heard about foreign function and memory API. Okay, so we have more than half of the people here that know about this one. That's great. So you know that it's been stable since JDK 22, and it's more efficient and doesn't have the same limitations that were typically associated with byte buffer API, and it's more programming model centered on the idea that everything that has to be safe when it comes to interactive with native libraries, and of course it has to handle timely deallocation because we are working with memory in the end. And well, we all know that its aim, being part of Project Panama, is to replace GNI on the long term with a new low-level API, which allows you to describe and link functions into a better way using method handles. And well, there are some explanations for those FFM bindings. So what FFM bindings refer to: memory layouts, meaning the way that the memory will be layout for you to work with, function descriptions to work with those memory layouts, var handles, and method handles. And while this sounds nice, and we can write by hand a lot of FFM code, and it's good practice to do that, there is a way to automate generating FFM bindings with a tool called jextract. So what jextract does, you can run it over a native library that has C headers, like .h files, and can generate for you these FFM bindings. So without further ado, because time is short, let's see it in action. So we're going to start simple. First of all, I have here 4 Java programs, each of them for a specific native language. And we're going to start easy with the time translator. And in the time translator, what I want to do, I actually want to use my native C library to save the time using that one instead of the Java time API. I know we have a native time API in Java, and we're using the C one. But just indulge me for this one. So we're going to start very easy. First of all, I have my C library path into a variable called C include path, just checking that is there. And next, I will run jextract for that, for generating some FFM bindings for the library time.h, the one that is in C that works with time. So first of all, I'm going to say jextract. But first comes first. Where did I get jextract? I was too nervous in jumping into demos, and I forgot to tell you where I got jextract. So I got jextract, well, from its binaries. So from time to time, there are early access builds released for jextract, so you can get it from jdk.java.net/jextract. And currently on my computer, I run with jextract build for JDK 22. But I'm generating FFM bindings, so it's okay that for me to use them with 23 too. If you want to build it yourself, you can also do that. This is an open source tool, so you can build it by yourself as well. That's something that I do too. But we can talk afterwards on how easy it is to do that as well. And at the end of the talk, I'll share a lot of links to the samples or where you can build your own jextract and more. So let's go back to the context here. So I want to use jextract to extract that time.h C library. So I can use that by saying jextract minus output. I'm using Java, so I want it to output in source. Then I wanted to everything to be outputted in the -t, which stands for the target package, target output package. So I'm going to say, hey, output this in org.unix under source. Then I need to tell jextract where they should look for my library headers. And my library headers are on the path C include path. That's why I said the -i back here to say look for the headers for this library on the C include path. But from this C include path, generate for me, yeah, this is the whole path. Sorry, time.h, just making sure that everything's there. Okay, no issues, the command ran. Let's see it, okay. So now I have a bunch of Java files here of FFM bindings towards my time.h. Let's write some Java here. So if I want to use some of the bindings there, I have to work with a way that I will that will control my memory allocation. And usually I use memory segments, and the way to control that is through an arena. So first thing that I want to do is to create an arena. And for this one, I will choose arena of confined. The reason for that is because the lifecycle of my application is kind of limited, and I'm okay for that to be of confined. There are 3 more types of arena. We can talk afterwards about the other types of arena and when they're coming handy. But for this short example, that's quite enough from my point of view. Now, I can use and say the time of now, and I can express it. And I can express it by working with the arena. So what I'm going to do now, I'm going to say, I want to, dear program, I want you to allocate some memory for my time, for my current time on my computer. And the way I can do that is using by allocate from, and using a constant that jextract has generated for me in time_h. Well, time_h, just for humor, it's a Java class. So by default, the jextract generates the Java by having the class of your library, which is time_h. Well, it used to be time.h, now it's time_h. You can beautify it and give it a name too. So let's going back to this. Okay, so this is the constant I'm going to use to allocate the memory segment for this. And of course, now I need to give it my time and split by 1,000. But it's also good for me to, maybe it will be easier if I just use memory segment. It's much more meaningful for you to see memory segments instead of vars. So memory segment for time, because I also need to bind the time perspective that I want to calculate here for when the time is on my computer with the actual time function that is written in C and was binded, and now it has a Java binding in the jextract sources. So in this case, I just need to do tm.allocate for my arena. So this is going to make the connection between the time, which is in time_h tm function, and the arena itself, the entire arena. What I can do next? Well, I can just call a very nice, oh, I just had only this one. I'm going to do this and import everything so I don't have issues further. So local time underscore R to, find out what the time is in the generated bindings. So local time underscore air of now time. And now let's print the time nicely. Now that we have the time here, first of all, I'm going to say TM, another binding that was generated for me. How convenient for this time. And of course, TM underscore min for the time. Okay, it should be fine. Now, let me run this program in the command line. So first of all, Java ---- enable preview, because I'm also using the implicitly declared classes, so I need to enable the preview for that. ---- source 23. And I think this should be enough. If I forgot something, it will tell me. Time translator.java. Okay, so we see the time is 1746, which is, I think, quite accurate. It's good. So it knows the time, it got the time through the same functions that had the FFM bindings generated for me. Now, something that you've seen here are a couple of warnings. Now, if you don't like these warnings, you can just get rid of them by using the ---- the enable native access all unnamed, so you're not going to see them again, and you're getting rid of it. Now, this was a very simple example. So porting C, that's what jextract has been meant for, purposely, like to create bindings for C libraries headers. But let's take our chances with Python. So I have my PyDukeMaker here, which is a Java program that gets some arguments and can create based on some string that looks very ugly, which is an encoded string for an image, can create me images based on a given file name. If I'm not giving any file name in my arguments when I'm running my program, it will generate a random name. So let's see how things are going on with Python. Now, Python, it's a little different story on my machine. So just getting the command from here, prepared ahead of time. Just clear this, and let's discuss it. So first of all, jextract, like before, I'm doing an output to a source. But unlike before, you see that I'm using here the -L, and there are 2 dots, and there's a path to a library. So what I'm saying here is that in the generated bindings that I'm going to obtain, I want for those bindings to always link to that library, that Python library, so that I'm not just generating, wrapping things from Python into Java, but I'm also connecting to the meaningful library of Python. Now, the big I, -I, it stands for where jextract should search for the headers. -T, again, the target of the generated, where the package should be generated with the Java code. And last but not least, which header interests me, and in this case it's python.h, because it's going to generate everything for me in Python. So let's run this. Okay, now more warnings. It can happen that when you're generating things, when you're generating bindings with jextract over your header library, over the header of the library, that it gives you warnings. Now, this means because these are given because jextract didn't know how to interpret those data structures. And in the end, they might actually not be relevant to your context, so you haven't lost much. But I'm going to show you a little later on how you can deal with those too. So this is my result. And we can go now to the PyDukeMaker. And with Python, I have, let me just check that I have my generated things with Python here. Yep. So Python, like always, when we need to work with it, we need to initialize things. So initialize. So this is also from the binding that was generated by jextract. I'm just following the naming as before, and just import stat. Usually the import static, the main class from the generated binding, it gives you everything in there. And like before, I'm going to need an arena. So it's going to be arena of confined. Then I need a memory segment to work with. So I'm going to say arena allocate from script, which is my Python script above. Then I can just say pyrun simple flags, simple string flags, because I provided that Python script as a simple string, so I can just run it like that. And I can say string, and I can use here the memory segment of null for the second argument of this. And of course, would be good if I finalize things with Python. Once again, to run the program, I'm just going to use the command before, just now with a PyDuke maker in my sources. Now, before that, there was a flag that was said, okay, the enable native access, well, it's good. We're just going to add it to the sauce here as well. And my expectation is that once I run this program is that an image is going to be generated for me using the inner workings of the library of Python to make an image based on the encoded string. Fingers crossed. Okay. And here it is. There's a Duke speaking. How nice of it to appear. So this worked pretty okay. There's time for another example. Okay, let's complicate things and look a little deeper. OpenGL. So the story of the OpenGL example, OpenGL used to be on the Mac, and it can still be available on Mac if you're installing Xcode and you have it available. I think that the framework itself, it is on Mac, but it's not the latest version. So what I did, I actually went and installed another free library that is for working with Glut and OpenGL. It's called FreeGlut. I also needed Mesa, which comes as a library for working with more graphics when it comes to Glut. And Mesa Glue because I needed some utilities to interact between Mesa and the FreeGlut. And it's something that apparently that's how it works on Mac. So that's how I discovered that things work on Mac. Now, similarly as before, when I'm creating the binding, I'm telling jextract, hey, this is the shared library that you should use when you're trying to link to do the down call to Glut. So this is where you find the library in this spot. But you should search for headers that the main header would reference in these three spaces. So because the headers of libraries, they can include headers of other that they can include other libraries inside them. So it's good to have them all linked together when you're generating things like that. And you see here that the command has also something called dump includes, Glut symbols. What would be that? So let's do this. Okay, oh, there's a fatal error. I've seen this before. Now, Mac OS is a special case. So whenever you get this error, this is a worked thing in the past. And so how can I fix this? Well, for Mac, there is a solution. You can add flags for jextract that are telling where the actual framework is. So if I'm adding this compile flags to my jextract, things should work. So let me add it here. Paste. Yes, I will compile flags. Yes. Let me clear and run again. Okay. Okay, a lot of warnings again, but this time it didn't generate me any code. The reason is because I said, well, actually dump for me the things and dump the files. What dump includes contains, it contains all the functions that you could generate using jextract, the functions that can be taken out from that header file. And that's pretty cool because you can filter and to generate only specific functions. And if you delete too much, jextract can tell you and advise you, like when you're going to run jextract for this with this filtered file, it's going to tell you, hey, you need this function, so you will need it and you'll put it back. But the nice thing with this is that, well, you can manually add in the command, this command. So this minus include function could be added to this big command. But this one has a couple of hundreds of lines, so adding manually every minus minus is not exactly the best thing that we can do as developers. And yeah, I don't want to spend my time, my developer time doing that. So one way to do that, once I'm filtering in such a file, is to give it like this and do it, and include those include functions and append this to my command. So I'm going to run it again. And here is my generated bind export. And why do I need this? Well, okay, let me close this because there's a lot of generated things. I didn't want to like modify it on the spot and see what's going on. Well, I generated this because I used to have a teapot written in C. And because I'm a very, very productive developer and I have used a lot of techniques in my lifetime, and this time I've used the great technique of copy-paste, probably a technique that is familiar to more of us. And yeah, I wrote this in C, but I was already a little bit bored for Java. So let me just say, I cannot move right. What I wanted to share with you is, but I can give you the code, is actually that I copy-pasted the code from C here. And the only things that I changed, well, the C code was having something like, well, we also have main in Java. And we don't have init, but we have constructors. So that's pretty much what I did. And of course, well, some things were not the same like in C, meaning for some of the constants that were in C, now I have functions generated. Now I have functions generated by jextract. So pretty much I changed that because the naming is the same, but the rest was kept like there was in my existing C file. And yes, of course, we are working with floats in Java. Well, in the other one in C, I didn't need to put the F there. So yeah, that was pretty much it, a lot of work. And as always, I had to add on top, before gluing it, the fact that I'm working with an arena, so I need to access native memory, and I need to allocate that native memory and give that memory segment to my glue-init method. So that's pretty much it. Long live copy-paste. Okay, let's see what I did in Java, first of all. And for this one, I'm going to use a special command. So because I'm working with OpenGL, and this involves graphical interfaces, I need to use the -x start on first thread, which is used to ensure that Java application starts on the main thread of the first available GUI event, blah, blah, blah. But what I want to show to you is that with jextract, you can also trace the down calls that are done to your native API. So there's a flag that's called trace down calls. I hope I remember it by heart. True. And let's start our Java application. Oops, I forgot something. Oh yeah. Clear. Java 23. Maybe that's what I forgot. I'm not gonna risk it again. Come on, teapot. Oh, cannot. Oh, a sec. Cannot initialize. No worries. I have something. Just give me a moment. Well, if this doesn't work, we can always rely on another helpful command, show project history. And what did I hit? This one. For sure this one is good. Yes. I can always rely on my Mac. Yeah, it's going to reference a different library, but yeah. So I need to just delete my free glute from here. So what this means is that when I'm going to run this command, and I'm just going to remove the symbols from here, just to make sure that I'm not including the wrong symbols. When I'm going to run this command, it's going to link to the native library of glue that is on Mac, which is a little bit outdated. That's not the only thing. That is a little bit disturbing, but not much. things still work. So let's run it again, the teapot, come on. Okay, it did something. So there's a teapot, a very green teapot. Now, the example that my colleagues from the Panama team did, it's much more dynamic. The teapot also moves. It's much more cooler than me, but this is what I can do with the C level that I know with OpenGL and so on, so that's my knowledge. What I wanted to show to you is that with that command of jextract trace down calls, you can see all the calls that are done down the native path. So you can see how the calls are being done by your application, and this is pretty useful when you're trying to debug. But then you're going to tell me, well, Anna, this works wonderful. Jextract works with everything. You can cook even with it. Well, yes, but there was a little catch. You need that C library header, the .h. And there are native languages that don't have it. For example, Rust. Rust is great, but it doesn't come with header files. So what do we do in such cases? Luckily, Rust has an utilitary called cbindgen that can help us generate native library headers, and we can export those, and furthermore, use jextract on top of those. So what I did, I actually took some inspiration from what my colleague Jorn Vernay did and put his project into reality. So I had a small Rust project here, and my build.rs is just saying, hey, when you're running the build, generate to the file lib.h. But also when that lib.h is being done, publish externally as a C library having this function called hello world. So when running cargo build, I get this lovely lib.h, which has the void hello world in it. Pretty nice. But not only that, so when I run the cargo build and is using the cbindgen utilitary, I also get the library that I should connect to. So in the debug, I have something called librust_Panama hello world.dlib, I think it's called. So that's the library that I'm going to say to my jextract that that's where you should do the down call. That's where you should link to. So let's quickly see how we do that. For Rust, just going to go apply also the old technique, so it's always good. So in this case, I'm doing again the output, the target to org.rust, and I say in this case, include only the function hello world, because, well, that's everything that I have in my lib.h, a hello world. I don't need the rest. And the rest of the things that I'm telling to jextract, hey, when you're going to generate the bindings, tell them to do the down call to this dlib that I have already in the debug folder. So that's why I'm saying that here's where you find the dlib on this path. And of course, the header file, the very complex header file of lib.h. Okay, it ran. Let's see if I get something here. Okay, we got Rust. Amazing. So let's see the simple Rust. A simple Rust, of course, invokes hello world, import static method, import it here, hello world. And of course, when needing to run this, I don't want the trace, simple Rust. I mean, I don't need the start from first thread, because there's nothing GUI that you're going to see. Oh, yes, I forgot the enable preview. Bear with me. Enable preview -- source 23. Hello world. That was written in Rust, but now is callable from Java. Isn't that cool? So, a few more things before my time's running out. Now, foreign function and memory API that give you access to the native libraries. And what jextract does is to automate that access to the native library to work for you when you need to generate bindings and don't spend time doing that manually all the time. But moreover, if you're wondering who adopted foreign function memory APIs, well, these stable projects that are in the slides, but if a lot more people are writing to the Panama team and telling about their experiments with a foreign function memory API and jextract. And for example, 2 weeks ago, there was a Swing conference, and some developers said that they took inspiration from jextract and they're building jextract Swing so that they can bring the magic of Swing programming language to Java as well. Now that's experimental, but jextract inspires people to make their own jextract for their own languages. Here are some few useful links. So try FFM API now in the latest JDK 23 as well. Subscribe to Panama Dev and just go and share your trials with jextract and with FFM API. I can tell you that the Panama team is one of the nicest teams that I've worked with. And even if you have things in progress, they're always like very, very nice and providing feedback. So just give them a shout out and just go on the mail and say, hey, I'm building this. I want to use your FFM API. We always like to hear about other cool projects. And speaking of cool projects, well, tomorrow morning there's going to be a deep dive done by my colleague Jose Bomar and by Remy Forax on foreign memory, the part of the foreign memory of the API. And Alina here, comfortably in the chair, is going to do a talk on Thursday with her colleague Alfonso on working with LLMs in Java. And that one is using under the hood foreign function and memory API and vector API. So that is putting the foreign function memory API into a more action, and also the vector API. The examples. Now, the examples that I showed today, they are pretty much a massaged way of the examples that are in the jextract sample. So you can find jextract samples for way more native libraries to inspire you into building your own. There's a link to the article of calling a Rust library with the Panama FFI. And of course, you can build the latest FFM API and jextract at those repos. So they're also buildable. You can build your own. They're very well explained. So give it a try. And if you're interested in the slides, here you find them. Thank you very much for listening to me. And the questions, I'll take them after the talk. I'm sure you have more questions to ask. And I have more things to say about using jextract with other programming languages. But my time is up.
All systems are nominal. Initialize Genesis sequence.